Okay, now we're on the statistical assumptions section. The first thing that I'm going to do is pool the variables from the hypotheses that we created last time during the descriptives videos. So I already put the variables from the hypotheses 1 in here, so you just need to pull the ones from the hypotheses that you came up with. So for correlation, our hypothesis 2 was people who enjoy country music will also enjoy Western movies. And then you also probably want to go up here and go ahead and run this structured data code. That way you can make sure that you are typing the variables exactly as they are in the data set. This will make everything easier later on. So here we're using country and Western. And then the next one is the independent t-test. Our hypothesis was only children will have more friends than people with siblings. And the two variables for that are only child and friends. Okay, let's see. Next, for chi-squared, we had males and alcohol, which was gender, and then alcohol. So gender and alcohol. Okay, and then the one-way ANOVA is the last one. People who use the internet will spend more on gadgets. So this one is internet usage and spending on gadgets. And then if you look over the structure that I ran earlier, I typed out these variables like they were in the data set. Okay, now we're going to test the assumptions for a correlation. Assumptions for a correlation include that both variables are normally distributed, both variables are linearly related, and that there's equality of variances or homoscedasticity between the two variables. So the skewness should be between 2 and -2, and kurtosis should be between 7 and -7 for sufficient normality. So we're going to go ahead and run the skewness and kurtosis for music and movies. And as you can see, this skewness value is -3, so that is outside this 2 and -2. -1.9 is within those values. 13, which is for music again, is outside of these values. And then 6.55, which is within 7 and -7 for movies, is good. So both of these are outside of the guidelines, which means that music is a skewed variable. So let's go ahead and take a look at the histograms. These both have a similar pattern, but as you can see for music, most of the answers are at 5, whereas very few people said that they disliked music. And movies is similar, but there is a little bit more data here in the center, although that is pretty skewed as well. So to answer the question, which variable is not normally distributed, the answer is music. And so in order to still do this correlation, one thing that we can do to make this variable normal is to dichotomize it and put all of the 1 through 4 answers in as 0, and then all the 5 answers in as 1. And by dichotomizing it, we're going to equal out those groups a little bit more. So to do this, you're going to give the new variable that you're creating a name. So we're going to put it in data, and we're going to call it music dichotomous. And then if data music equals 5, then we're going to have it be 1, otherwise 0, or else 0. If 5, then 1, else 0. Okay. Now, if we run music dichotomized in skewness and kurtosis, we see that these values are now within the limits for normality. And if you run the histogram, this bin is now a little bit bigger, which makes it comparable to the 5s. And we can still run a correlation with this, so it'll just be a 5 Pearson's correlation, but we can run a correlation between a dichotomous variable and a continuous variable if they have sufficient normality. Okay, next we want to see if the variables are linearly related. So we're going to create another scatter plot by doing plot and then tagging the x variable and then the y variable. Basically what you're looking for if these were continuous variables is you want this to be parallel to each other in the distribution of the data points. You don't want a funnel-shaped graph in the scatter plot. Okay, and then we want equality of variances or homoscedasticity. We want the ratio of variances to be no greater than 2 to 1. So we're going to grab the variance for movies and the variance for music, and those are very close to each other, so that's very close to 1. A 1-to-1 ratio. So we're good there.